Solving basic trig equations, part 3. We want to solve for t. We want exact answers, no calculator. We're working in radians. And this time, we're not finding all the solutions, just the ones in the interval 0 to 2 pi. Notice 0 is a possible answer, 2 pi because of the parentheses is not. Okay, step A. I need to clean this equation up until it looks like this. Well, let's get this secant t by itself. I'll subtract 3 root 2 from each side. Let's see, 1 root 2 minus 3 root 2's would be negative 2 root 2. And divide both sides by 2. So I have secant t equals negative root 2. I don't want to use secant t though. I want to use only sine, cosine, or tangent. Well, it's easy enough to switch to the cosine ratio by simply reciprocating the secant ratio. If secant t is negative root 2, then of course cosine t is negative 1 over root 2. Now I'm thinking to myself, should I rationalize this denominator? I don't think so. We like this answer typically unrationalized. I'm already picturing the triangle. Well, that takes me to step B. I need to find all the solutions to that equation within one period. All students take calculus. Where can the cosine ratio be negative? Not here and not here. It's negative in quadrants 2 and 3. So that's where my picture is going to be. I have a second quadrant angle, so this angle right here, with a cosine ratio of negative 1 over root 2. Cosine is adjacent over hypotenuse. And then I have a very symmetrical third quadrant angle as well. So this angle, also with a cosine ratio of negative 1 adjacent and root 2 hypotenuse. Of course, we've drawn these triangles a million times. These are just the 45, 45, 90 triangles. So let's put some labeling in here. This little thing is a 45-degree angle, and this little thing is a 45-degree angle. I think we have a picture that's good enough now for me to write down those solutions. Would the inverse cosine function have told me anything? Well, inverse cosine only knows angles between 0 and pi. One of those answers is between 0 and pi, so one of the answers is what the inverse cosine function would tell me. The other one, though, is really only obtained from this picture. So what are those angles? Well, let's see. If this is 45, then this second quadrant angle is 135 degrees, which in radians is 3 pi over 4. And then, let's see, this other angle is 45 past 180, that's 225, which in radians is 5 pi over 4. Those are the only two solutions to the equation within one revolution. Well, now I come to the part where I add in multiples of the period, but here's the thing. Here's why it says if needed. This one doesn't require all the solutions. I only wanted the solutions within one period, 0 to 2 pi. Well, that means I'm finished. These two solutions are the only two solutions in that interval for this equation. Thanks for watching.